Hello and welcome. This is physics paper number 1, multiple choice. The subject code is 5054. This is May-June 2019 exam. And this is version 1 of this paper. Let's start. First question, it says which quantities are both vectors? So first is acceleration. Yes, acceleration is a vector quantity. Length, no, length is a scalar quantity. So acceleration is a vector quantity. Length is a scalar quantity. Then distance. Distance is a scalar quantity. Velocity is a vector quantity. Then we have length. No, length is a scalar quantity. Distance again is a scalar quantity. Then we have velocity is a scalar quantity. Acceleration is a scalar quantity. So then answer D is the right choice we have. Next question. Question number 2, it says forces X and Y act as shown. Which diagram shows the resultant force R of X and Y? So we have two vectors and simply use head to tail rule. So head to tail rule or so head to tail rule. So say for example, it starts from here. uh, The head of this vector is here and the tail of this Y vector is here and head is here. So, and the resultant would be this vector R. Okay, so let's see which figure shows this resultant vector R. So A, no, B, no, the resultant R is like this, D, no. So answer C is the right choice we have. Next question. Question number 3, it says which reading is given to 1/10 of a millimeter. Okay, so 1 millimeter is 10 to power minus 3 meters or 0.001 meters. Okay, so 1/10 of a millimeter. So which reading is 1/10 of a millimeter, and all these readings are given in centimeter. So 1 centimeter is equal to 100. Oh, sorry, not so 1 meter equals to 100 centimeters. So I can write 1 meter equals to 100 centimeters, and 10 to power 3 meters is equal to 100 centimeters, and no, sorry, it's my bad. It is 100 centimeter and 1 centimeter is 10 millimeters. So this is how it looks. So from here we can see that 1/10 of a millimeter. So 1/10 of a millimeter is 1/10 of a millimeter is 0.1 centimeter divided by 10. So 0.01 centimeter. So uh, eventually, which reading is given to 1/10 of a millimeter? This one, no. This one, no. This one, yes. Again, this one, no. So answer C is the best choice. So what other way we can say we can come about something like this? So just convert this into millimeters. So let's see what we get. So this is 33 millimeters. This is 33.1 millimeters. This is again 33.10 millimeters, and this is again 33.12 millimeters. So the best choice we have is 1/10 of a millimeter is this. Answer C is the best choice we have. Next, question number 4. It says the magnitudes of 3 different electric charges are given below. What is the correct order of size from largest to smallest? So we have milli, mega, and kilo. So mega is the largest, then we have kilo, and then we'll have milli. Size of charge from largest to source, mega coulombs, kilo coulombs, and millicoulombs in this direction if we have something. So mega, kilo, milli. Answer C is the right choice we have. Next question. Question number 5. It says 4 of the gravitational forces that act between bodies in the solar systems are listed below. P is the force on the moon due to Earth. Q is the force on Earth due to the sun. R is the force on the Earth due to the moon. And S is the force on the moon due to the sun. Which of the two forces are a Newton's third law pair, action and reaction? So for example, this is my Earth. This is our moon. And this is, for example, the sun we have. P is the force of moon, force on the moon due to Earth. So P is this force. Q is the force on the Earth due to sun. Force on Earth due to the sun. This is Q. R is the force on Earth due to moon. So R is on Earth due to the moon. And S is the force on the moon due to sun. So S is the force on moon due to the sun. So action and reaction, P is equal to R. These are the two, P and R are the action and reaction. So answer B is the right choice we have. Then next question, question 6, it says hot air balloon is traveling at constant velocity and is at constant height above the ground. The diagram shows the only 4 forces acting on the balloon. So these are the 4 forces acting on the balloon. Which statement is correct? So which of the statements is correct? So we have, so the balloon is traveling in this direction. So we have 1, 2, 3, and 4, these forces. So, and this balloon is traveling with constant velocity. Okay. So constant velocity, and it is at a constant height above the ground. So it means that if it is at constant height above the ground and it's moving in with constant velocity, it means that W and Y will be equal. So W is equal to Y. And if it's at the constant height with a constant velocity, it's nothing is changed. So means that X and Z will also be equal. So we have these two. So Y and X equal yes, X and Z equal yes. Y equal less, no. No. X and Z equal yes, Y no. No. So answer A is the right choice we have. Next question. Question 7, it says the diagram represents an object O moving from X to Y along a circular path at constant speed. Okay. Which is the direction of resultant force on O in the position. So if an object is moving in a circular path at constant speed, the force or the resultant force on the object will be towards the center of the circle. So if this is the circle, the object, object is from X to Y, and object is moving in this direction, the center of circle is towards D. So answer D will be the right choice we have in this case. Next question, question number 8, it says 4 objects of different masses are situated in places with different gravitational field strengths. Which object has the highest weight? So remember, weight is equal to mass times gravity. So we are given with mass and we are given with gravity. So just make a column W equals to mg, multiply both 3 into 10.4, this becomes 31.2, 3.5 into 9.5, this becomes 33.25. So what we are doing here is 10.4 multiplied by 3. This is 3.5 multiplied by 9.5. This is 4 multiplied by 10.2. This becomes equal to 40.8. And this is 4.5 multiplied by 9. 9 becomes 40.5. So greatest weight, this answer C is the best choice we have. Next question, question number 9. It says the uniform meter rule is balanced by a force, 4 Newton force as shown. So 4 Newton force is acting here. The weight of this rule is acting down. What is the weight of the rule? So just use the principle of moments and taking moments around point P. So if we take moments around point P, it becomes 4 newtons multiplied by 10 centimeter, and then it becomes 50 minus 10. This length is 40 centimeters multiplied by weight. So we get 40 Newton dot centimeter divided by 40 centimeter is equal to W, and this is equal to 40 newtons. Sorry, 4 newtons. Not aha. This is equal to 1 Newton. So answer A will be the right choice we have. Next question, question number 10. Which statement about the center of mass of an object or center of mass is correct? So part A, objects with center of mass at center of mass at the same height are less center of mass at same height are less stable when the base is larger. No. So when the base is larger, center of mass is up or is different. The one with the center of mass higher will be less stable. So objects with or in this case, both of these objects will be having same stability. So objects with center of mass at the same height are more stable when the base is larger. Yes. So if the height is the same, and if we increase the base, the objects will become more stable. Yes. So objects with higher center of mass and smaller bases are less stable. Objects with identical bases are more stable, okay, when center of mass is lower. So these two, now again check, object with center of mass at same height is more stable when the base is larger. So answer B is the right choice we have. Next question, question 11. It says garden table with weight 60 Newton has a top surface area of 2 meters square. It is raining and the rain produces a pressure of 4 Newton per meter on the table. Newton per meter square on the table. Ignoring the pressure of the atmosphere, what is the force exerted by the table on the ground? Okay, so force exerted by the table on the ground. So say for example, this is your table. This is the ground we have. So table is here. So weight of the table is 60 newtons. Then atmospheric pressure because of rain. So pressure because of rain is force per unit area. Force is 4 divided by, and it is multiplied by the area. Area is 2, so it is 8 newtons. So total force will be 60 newtons plus 8, it would be 68 newtons. So if there is an option, yes, we have answer D. That is the right answer in this case. Next question, question number 12. It says the diagram shows a manometer containing mercury that is sealed at one end. So this and one end is sealed. What happens to the distance h when the manometer is taken higher up the mountain? So higher up the mountains, we have the atmospheric pressure decreases. So if atmospheric pressure decreases, this height will uh, h will decrease. So what happens to height? The height decreases, yes, because atmospheric pressure decreases with height. Yes, height decreases, atmospheric pressure no. It decreases. It decreases with height. The height not increases. The height will not increase. Okay, so answer A will be the best choice we have. Next question. Question 13, it says some doctors measure blood pressure using a mercury manometer. Blood pressure varies by 50 kilopascals as heart beats. The density of mercury is 14,000 kilogram per meter cube, and the gravitational field strength is 10 Newton per kg. What is the change and the difference between the levels of manometer during the heartbeat? So again, the pressure is equal to rho GH. So you can go with this. So density of mercury 14,000 kg per meter cube multiplied by gravity. Again, it is 10 Newton per kg multiplied by height. That we don't know, and pressure is 5.6 into 1,000 kilo pascals, Newton per meter square. Okay. So if you go and check the room, that's fine. So the height will be 56 into 1000 divided by 14,000 multiplied by 10, and this value of h comes out to be 0.04 meters, and it's in millimeters. So 1 meter is equal to 100 centimeter is equal to 1000 millimeters. To multiply it by 1000, we will get multiplied by 1000, it will get 40 millimeters of Hg. So during the heartbeat, answer A will be the best choice we have. Next question, question number 14. It says the diagram shows a stationary fair ground, right, with small chairs, for 4 chairs of equal mass. Each chair has which chair has the most gravitational potential energy? So gravitational potential energy is mgh. So mass is the same, gravity acting on all these chairs will be the same. So it depends upon the height. The higher the table from the ground will have the most potential energy. So d c. So the most will be a, followed by a will be greater than d, d will be greater than b, and c. So this is the order of the chairs having potential energy. So answer A will be the best choice we have. Then question number 15, it says the diagram shows a small car of mass 500 kgs approaching a hill. It moves up the hill with a constant speed. The gravitational field strength is 10 Newton per kg. Ignoring the friction, how much work done in moving car up the hill? So work done is basically the amount of energy that is stored or energy gained by the car from moving from this level to this level. So that is the potential energy. Potential energy is mass into gravity into height, and this becomes 500 multiplied by 10 multiplied by height is 10 meters. So this is 5000. So 50,000 or 50 kilojoules, that is the potential energy, and the work done uh, will be yes. So this is the energy. So this is joules. So 5 into 10 to power 1, 2, 3, 4. So 5 into 10 to power 4, it can be written as 5 into 10 to power 4 joules. So answer B will be the right choice we have. Then the next question, question number 16, it says which statement is correct? Infrared radiation can travel through vacuum. So this is not infrared radiation, cannot travel through solid and gases. Again, can travel through solid and gases. Infrared radiation can only travel in vacuum. No, it doesn't. I mean, it can travel in other dimension as well. It can travel in vacuum, yes, and in gases, yes. Solid is difficult for infrared rays to travel. So answer D is the best choice we have amongst these options. So next question, it says. Question 17 says the diagram shows a set of apparatus used to determine the specific heat capacity of water. What does not affect the rate at which the energy is lost to the surrounding? Insulating the container, it will decrease the rate of energy lost to surrounding. So yes, placing a lid on the container, it will also decrease the energy that is going out from the top. No, polishing the outer surface, it will become a good reflector of energy, so it will not affect. Moving the thermometer closer, so now moving the thermometer closing will have no effect on the energy that is lost to the surroundings. So answer D will be the best choice we have. Then question number 18. Question number 18 is two thermometers X and Y contain different liquids, but otherwise identical. So two thermometers are identical, have different liquids. The thermometers are heated through the same temperature rise. So the volume of liquid in thermometer X increases by more than the volume of the liquid in thermometer Y. So for example, this is thermometer 1, and say this is thermometer 2. For same delta T, we have, so this is X, this is Y. So X has risen up to this, and Y has risen up to this. And the temperature, which is more sensitive thermometer when the thermometer and which thermometer is with larger range. So Y will be having more range and X will be more sensitive. Okay, so more sensitive thermometer X, not Y, more thermometer with larger range Y. So both tick is answer B is the right choice we have. Next question, question number 19. It says it's another question related to thermometer. So it says the diagram shows two thermometers P and Q that are identical, except P contains less amount of mercury. So there is less amount of mercury in P than Q. Which statement is correct? Uh, the lowest measurable temperature is the same on P and Q. No, that is not the case, because we have less amount of mercury. This will start to rise earlier. So no. The range of P is equal to range of Q. No, the range of because we do not have same amount of volumes of mercury. So for same temperature rise, the range will the rise in temperature or the rise of mercury in the column will be different. So that is why the range will be different. Scales on both P and Q are linear. So by looking at it, they both looks linear. So that is fine. Sensitivity of P is equal to sensitivity. No, the sensitivity of both of them are not equal because the volume is less. So answer C is the best choice we have in this case. So next question, question number 20. Question number 20, it says the diagram shows air trapped in a flask by a volume of water in a thin tube. Okay. When the flask is held in student's hand, the small volume of water first moves down from P to Q and then up to R. So first the volume it moves down and then from Q to R it moves up. So why does the volume of water move like this? So let's see what are the options. The flask contracts and the air expands. No, the flask is not good. The flask expands and the air contracts. No, there is no something like that. So air is not. So basically, what's happening? So when students is holding in his hands some of amount of energy uh, um going to the flask, and flask actually expands. So initially when the flask expands, the Q comes down, and once Q comes down, the energy from the expansion of flask is taken up by the air molecules, and they start to heat up again, and then the air expands, and then your Q moves up. So first the flask will expand and the air will expand. Okay, so flask expands, yes. Air contracts, no. Flask expands and the air expands less than the flask. So if air expands less than the flask, it will come down. So no. So air expands more than the flask. So flask expands, the air expands more than flask. So answer D will be the best choice we have in this case. Next question, question 21, it says which statement about particles in a liquid is correct? They all have same speed. No. They are stationary. No. They move at random. Yes. They vibrate about fixed position. No. This happens in solids, not liquids. So answer C is the best choice we have. Next question, question number 22, it says a gas is enclosed in a container of fixed volume. The gas gains heat energy from an external source. What happens to the molecules of the gas? So remember the volume is fixed. So PV equals to nRT. So nR is also fixed. The volume is also fixed. So what we have to do, we are given with PVT over T equals to nR over V. So this remains, or this should remain constant. P over T ratio should remain constant. Um, so it gains heat if heat if the temperature is increased. So if we have to keep this value as constant, if this increases, pressure should increase, so that so if pressure is increased, they vibrate with more frequency. So yes, they start vibrating with more frequency, but this happens in you can say solids. They move further apart. Again, the volume is fixed. So if if the move further apart, the volume will change, so it will not happen. They move faster inside the container, yes, because if they move faster inside the container, they'll exert more, there will be more number of collisions per unit area, and that will increase the pressure. uh, so what happens with, they vibrate with greater frequency, so vibration with different frequency, so they are actually not vibrating, they are basically moving. So vibrate is like at, you are at one point and then you are moving around, so that happens actually in solid. So answer B is the best choice, because that is actually the reason for increase in temperature, sorry, a reason for increase in pressure. Then question 23, it says which waves are longitudinal. Remember, sound waves are the only longitudinal waves that are, as per our curriculum, we are dealing with. So gamma rays, no, these are not longitudinal. These are electromagnetic waves or transverse waves. Again, light waves, no. X-rays, no. Ultrasounds. Answer C is the best choice. Next, question number 24. A ray of light strikes the mirror at an angle of 20-degree incidence. So for example, this is the ray of light is coming, incidence angle is 20 degrees, reflected rays again 20 degrees. The angle of incidence is increased by 5. So if I increase the angle of incidence, now my angle of incidence is 25 degrees. What is the new angle between the incident ray and the reflected ray? So the angle between incident and the reflected ray is 25 plus 25, 50 degrees. So answer D is the right choice we have. So next question, question number 25, it says a parallel beam of light on parallel beam of light is incident on a thin diverging lens. The focal length of the lens is shown, the position of the diverging lens. Okay, which ray shows the beam after it passed through the lens? So this is, remember, a diverging lens. The diverging lens is something like uh, this. So this is my diverging lens. So first light of ray will come like this. The second level will come here and it will go something like this, and the image will be formed at the back. So it will be something like this. So first ray will pass it through the center of the lens. It will keep its path. So first ray will keep its path. This ray will know. This ray will not burst. This is right. So no, this ray will keep its path, this ray will diverge. Yes, so answer C looks good. So this is not the case. So answer C is the best choice we have in this case. Next, question number 26. It says the following list shows the colors of spectrum. Which list shows three colors of increasing frequency? So remember, VIBGYOR, VIBGYOR. So this is 400 nanometers to, this is 700 nanometers visible spectrum. So frequency, so wavelength lambda increasing. So if lambda is increasing over here, frequency is increasing in this direction. So anything blue, then violet, yes, then red, no. That's green, blue, green, green, yes, blue, yes, violet, yes, red, no. First is red, then orange, then violet. Okay, then yellow. No, violet should be later. So no, this is so red. Yes, orange, yes, yellow, yes, green, yes. Then comes blue, then indigo. So it's not in violet. Yes. So answer D is the best choice we have in this case. Next question, question number 27. It says four sound waves are displayed on the screen of cathode ray oscilloscope. Which sound gets louder and the pitch that decreases? So the louder sound, as the sound gets louder, the amplitude should be getting higher. So as the uh, amplitude is getting higher, amplitude is, as we see, this is the amplitude, then this is getting higher. So yes, this is amplitude getting higher as its sound progresses. And this is the amplitude that is getting higher as the sound progresses. Um, so these two can be so louder. So these two are the louder sound as gets loud, and then the pitch that decreases. So pitch decreases means that the wavelength should be increasing. So we are decreasing the wavelength and we are increasing the. So answer B will be the best choice we have. Next, question number 28. It says students investigates permanent magnet by suspending paper clips from the magnet as shown. Which statement is correct? So each paper clip has south pole at top and north pole at the bottom when suspended from the permanent magnet. This is north here, south here. This is north for this, south for this is north for this, and this is south for this. So south pole, no. If paper clips are made up of soft iron, they become demagnetized when the permanent magnet is removed. So if these are soft iron, uh, this if I remove this permanent magnet, these paper clips will lose their magnetization. So yes, this is true for soft iron. Then part D, it says paper clips are made of steel. They become demagnetized. No, so for steel they become magnetized when paper true. This is not the case. More paper clips will be separated from the North Pole. Now that is not the case. So answer B is the best choice we have. Next question, question 29. It says two vertical lines passes at right angles through a piece of card. There is a large current at each wire in each wire in the direction shown. So this is current into the page and this current out of the page. So plotting compass. So remember, if you use your right hand thumb rule, so the magnetic field lines will be something like this across this. And if we are going to plot this, the magnetic field lines will be again like this. So in both cases, if we look over here, the magnetic field lines will be going in this direction. So answer C will be the best choice we have in this scenario. So use, remember, right hand thumb rule. Okay. So moving ahead, question number 30, it says the diagram shows a car ignition switch and a starter motor. The ignition switch in the circuit with thin lines, long thin wires. The starter motor is a circuit with short, thick wires. Okay. Which explanation is the choice of wire? So remember, ignition circuit, long wires and thin. So remember, resistance equals to rho length per unit area. So longer wires and thin wires. So long wires, less area will have more resistance. So this will be more R. Starter motor with having lesser lengths and thick wires. So for low lengths and greater areas will have low resistance. Okay, so let's see. Each circuit needs to contain the same mass of wire. No, that's nothing to do. Thicker wires heat up more quickly when the relay switch is switched on. Okay, we can see the thin wires have a low resistance. So yes, this is true. But what is the explanation? Choice why we need it. So the ignition switch carries a smaller current than the starter motor. Yes, that is the reason. So for smaller currents, we can't go with lower value of resistance. So then, um, so so we have to handle smaller for the starter of motor, we need to have the low resistance so that most of the current goes to the motor for starting purposes. So answer D is the best choice of answers we have in this case. Then question number 31, it says the diagram shows some white plastic beads in a clear plastic box. So this is a clear plastic box, white. The box is shaken and rubbed against the box. The beads stick inside the surface of the box. Which of the possible explanation for this? So the box may, if they're sticking here, so one of these entities is positively charged and the other is negatively charged. So for example, if box gains electrons, then the beads must lose electrons. Or if the beads gain electron, box must lose electron. Then it's the case, one will have negative charge and the other will have positive charge. So box gains electrons, okay. No change in electrons, no. Then the beads should have lost electrons to stick. Box loses electrons, beads gain electrons. Yes, this is a good choice. Then box no change in electrons, then what's the point beads losing electrons? Okay, then again no change gaining electrons. So answer B is the best choice we have in this case. Next, question number 32, it says which is the unit same as volt. So V equals to IR, volt is equal to ampere times resistance or ohms. So volts is ohm per ampere. No, okay. So let's see power. So what is power? Power equals to V times I, and power voltage is equal to wattage divided by ampere. So this is another unit of power. So wattage divided by ampere, T is another entity that has the same unit as volt. Okay, next question, question number 33. In this question, it says the voltage current graph of a metal wire is shown. Voltage is there. The gradient of the graph represents. So there is change in Y, change in V divided by change in I. So delta V divided by delta I is equal to R, resistance. But so it is the charge passing through, no EMF of the battery, no energy produced in the wire, no resistance of the wire. Answer D is the right choice we have in this case. Next question, question number 34. It says the symbol of the device that measures current. So measures current is done by ammeter, and ammeter is a symbol like this. So let's see. Answer A is the best choice we have. Next question, question number 35. It says cable to an electric cooker remains, cooker contains a live wire, a neutral wire, and an earth wire. When the cooker is working correctly, which of the wires are the current, which wires are the, or in which wires the current is equal. So live wire is the one that is carrying the current, yes. And so technically there should be no current should be flowing through the earth wire. So the live and the neutral wire must be having same amount of currents. So answer neutral wire, live wire, yes, earth no, neutral and earth no. So answer D is the best choice we have. Then question number 36, it says the coil of a simple motor lies between poles of a permanent magnet. The coil rotates about its axis when there is a current in it. Okay, so a current carrying coil is placed inside a magnetic field. So what decreases the frequency of rotation of the coil? So increase the number of turns, the frequency will increase. So no. Reversing the current, the rotation will remain, the frequency of rotation will remain the same, but the direction will change. So no. Lower the voltage supply, yes. Lowering the voltage supply will decrease the frequency of rotation. Yes, using a stronger magnet will increase the frequency of rotation. It will basically increase the force. So answer C is the best choice we have. Then question number 37, it says the beam of electrons traveling through the vacuum. The beam passes through the poles of the magnet. So poles of the magnet, so poles is between north and south. The direction of conventional current. So what is the direction of conventional current and is the direction of the magnetic field? So conventional current is against the flow of electrons. So the conventional current is something like this. This is current or conventional current. Okay, so the conventional current in this direction, so this and this are the right choices, this is not the right choices. Okay, then the direction of the magnetic field, the direction of the magnetic field is from north to south, from north to south, this and this is not. So both two cases, answer D is the best choice we have. Then question number 38, it says the teacher uses a circuit shown. The identical lamps X and Y are connected to a low voltage AC supply. So this is a low voltage AC supply by high resistance transmission line. Both lamps are switched on. So both lamps are switched on. Lamp X is switched off. Lamp Y stays on. So now both are on. Then X is switched off and Y remains on. What happens to the voltage and power supplied to the lamp at Y? So mm, um, what will happen? This is V volts. The resistance of transmission lines is R, and if both lamps are on, the current drawn is, say for example, I. So I is drawn by here, this one, and I is drawn by this one. Okay. So the total current is, say, for example, I. This is I by 2 goes here, and this is I by 2 goes here. So now if I switch off this current, so what will happen is that my current will reduce to, or the current drawn will be I by 2. Okay. Uh, and the resistance remains the same. Uh, and this is the current that is now flowing between these this wire, and I square R losses will be happening. The first case, they will be I square R, and in the second case, they will be I square by 4 in times R if my X is closed. So my losses are reduced. So actually more power will be available at Y. So the power supply to lamp at Y will increase. Then it comes to voltage supplied to the lamp. If there is this I square R, there will be some voltage drop against this line. So if the current and that voltage drop is V equals to IR, now the voltage drop across this transmission line will decrease. That will be I by 2R. So this is now V trade drop 2. So the voltage that is available over here, that will be V minus V drop 2. So this voltage drop is less. So actually more voltage will be available for me when Y is there. So answer C is the best choice we have. Next question, question number 39. Question 39, it says a car battery supplies the current in one direction. Okay. The current in opposite direction recharges the battery. Which circuit recharges the battery using AC supply and a diode? So remember, a diode blocks the AC signal. So for example, if this is an AC signal, this is a diode that is connected in this fashion. It will allow the positive half, but it will block the negative half cycle to come. And that will help you charge the diode in one direction. Okay. So in say this case, the positive signal will come, the positive will come, the negative will not come. So the positive will come, it will go like this. In this case, the negative signal will come, and it says battery supplies in one direction. So battery is supplying, say for example, in one this direction, the current in opposite direction. Battery supplies the current in this direction. Okay. So this is the from positive to negative, the battery supplies this. So the direction of current that is in opposite direction should be the one that is charging. So it means that the current should be flowing in this direction. Okay. So the negative current is coming. So negative current will be in this direction. So now this is, I mean, this is not a circuit. Diode can't be in parallel with this. So this is no way that between these two are not actually the charging circuits. That diode is acting in parallel against this battery. And so eventually we can see that the current supplied by the battery is in this direction, and for the positive half cycle, the current from the diode circuit that charges it will be in this direction. So in the positive half cycle, the battery will be charged. So answer A will be the best choice we have. Then last question for this exam, it says a neutral atom of boron contains 5 electrons and 5 protons. So we have same number of protons and same number of electrons. So the nucleon number or the mass number is 11. What is the number of neutrons? So mass number minus protons or electrons, so answer is 6. So answer C is the right choice we have in this case. So this is all folks for what we have for this exam. I hope you would have learned something from this video, and all those who are appearing for their exams, I wish them best of luck. If you have any questions or any queries or any difficulties in understanding what I have said, please write down or please send me your message in the comment section of the video. Thank you very much. Best of luck for your future endeavors.